This video is for homework 13 and it's covering dividing monomials and using negative exponents. So the rule we're going to use for dividing monomials is that we are going to subtract the exponents with the same base. So for number 1, that means that I have a base of 6 exponent of 7 divided by base of 6 exponent of 4. So I'm going to write that base of 6 one time, and then I'm going to subtract the exponents. And so the directions tell us to write your answer with an exponent, so 6 to the third. We don't actually have to figure out what 6 to the third equals. Then number 2, I have x to the 8th over x to the 4th. So I have the same base of x, and then I subtract the exponents. So top exponent minus bottom exponent. And then I have my y's, top exponent minus bottom exponent. So this now becomes x to the 4th, and this is y to the 0. And when we have an exponent of 0, whatever it's attached to becomes a 1. So the final answer for this one would just be x to the 4th. Number 3 is just a little different because I have the 15 over the 5, and they don't have exponents directly attached to them. So those are going to be divided. So what I have is 15 divided by 5. But then, so then we take the base of x and we subtract the top exponent minus the bottom, and the bottom x doesn't have anything on it, so that's an invisible 1. Same with the y down here. So then we take the exponent of, or the base of y, and subtract the exponents. So now I have 15 divided by 5 is 3, and then x to the first power, and then y to the second power, 6th power. So when we have a negative exponent, we are actually going to flip over the problem and make the exponent positive. So I'm going to take that fraction and flip it over. So now it is 4 over 3 to the positive 1, which is still 4 over 3. Okay, so the rule for negative exponents is that a base with a negative exponent moves and the exponent becomes positive. So this has a base of 3. So right now, that is on top of a fraction. So I am going to move the big base of 3 and put it on the bottom. And then this exponent of negative 3 goes with it, but now it becomes positive. And then our directions say to write your answer as a fraction with no exponents. So this means 1 over 3 times 3 times 3. And that is 1 over 27. And that is my final answer. So number 6, it is not a fraction to begin with, so I'm going to make it a fraction. And then I have x to the positive 6. That stays right where it is. But then the y to the negative third, that base of y has to move to the bottom. And that negative 3 exponent becomes a positive 3. And this can no longer be simplified, so that's our answer. So then number 7, this is a fraction. So the x has a positive exponent of 1, so it stays on top. This y to the negative 4 is on bottom, so it moves to the top of a fraction and the exponent becomes positive. And because we don't need a bottom to a fraction, we can have xy to the 4th as our answer. And then number 8 is a lot like number 6. So this is not a fraction. I'm going to make it a fraction. and then my 4 to the negative 4, the 4 goes on the bottom, and then the negative 4 changes to a positive 4, and we can't have the top of the fraction empty, so I have to put a 1. And then again, this means 1 over 4 times 4 times 4 times 4, which is 1 over 256. So on number 9, again, it's not a fraction, so I'm going to make it a fraction. And I have a base of 4. So it's going to go on the bottom. And then that negative 2 goes with it on the bottom and becomes positive. And then I can't leave the top of the fraction empty. And of course, I have that minus sign that was in front of the 4. So then this means negative 1 over 4 times 4. And that gives us negative 1 over positive 16. Okay, so on number 7, we have the exponent of 0. And so anything that has an exponent of 0, that base becomes a 1. So my 7 stays, the x stays, but that g to the 0 becomes a 1. So 7x times 1 gives me 7x. So 11 starts as a fraction, and so I am going to, I will leave the 1 where it is, and then this p to the negative 13 will have to move to the top of the fraction, and then the negative 13 becomes positive. So the way we want to enter that into Math Excel or to write it on our answer blank is just p to the positive 15th power. Number 12 is not a fraction, so I'm going to make it a fraction. X to the positive 5th stays on top, and then I have y to the negative 3rd. The y comes to the bottom, and that negative 3 becomes a positive 3. On number 13, this exponent of 0 makes everything in that parentheses a 1. And that is only because there is a set of parentheses. So the entire term becomes a 1. So on 14, I have p to the 4th over p to the 2nd. So I'm going to write that as, write the base once and then subtract my exponents, and the same thing with q. Write q once and subtract my exponents, and remember there's an invisible 1 right there, so minus 1. So now I have p squared q to the 8th. And 15, the last one, I have 9 and 27 that are not attached to an exponent, so that's just 9 over 27. And then I have h top exponent minus bottom exponent, and then b top exponent minus bottom exponent, and there's an invisible 1 right there. So 9 over 27 reduces to 1 over 3. My h to the 9 minus 9 is h to the 0. And then b to the 5 minus 1 is 4. But that h to the 0 becomes a 1. So I'm going to write my final answer as b to the 4th over 3.